what we know now, the most common medication they use to treat the MS. And by the way, when you type MS treatment into the Google, you will see that there are many non-traditional treatment in there. Non-traditional because when you have a bunch of non-traditional methods, we don't know exactly how to treat them yet. However, this medication commonly described, they call interferon beta. Okay, there are different types, 1A, 1B, Anavex. Okay, and beta, Sauron, all of that medication only do one thing in common. They just make sure that all the symptoms are tolerable. In other words, you won't have to deal with all those things. They only keep your symptoms at base. It doesn't treat the cause of it. Okay? Do you know that? That's why a hormone research still required. Let me introduce you guys to the new terminology. And that term, go ahead, Harry.
Yes, sir. If sodium ion is so important in the body, why are the physicians advocating reduction in sodium intake?
One more time slowly. If
sodium is so important in the system of the body, why
if the potassium,
sodium
is
so important in the system of the body, why are the physicians advocating for reduction in sodium chloride intake? So.
Oh, I'm with you. Okay. Remember that. You always have sodium in the body. Okay. As a matter of fact, when you have enough sodium, that's a problem, right? What you're talking about is there's certain condition they treat hypertension. You consume too much sodium than you need it. And they usually recommend that for certain condition, very common hypertension. Because you learn, sodium go, what go next? The water follow. So if you have hypertension, your blood pressure is already high, and you eat salty food. If you eat salty food, now you draw more water into your blood. That would increase. So that's why they say control your salt intake. That means that they never say get sodium free. You cannot do that, right? But reduce your sodium intake so that you won't burst your blood vessel because of that. Yeah, we all need sodium. All right, go back to this. I'll introduce, I think what's the romantic term that you should learn. Everything to me is romantic. Okay? Now, how many times you have heard I said that? Here is a mononeuron. The mononeuron sends an axon, and this axon contact the muscle. You remember that? Right? Okay? Well, in the brain, a neuron may contact the other neuron. But we don't use the term contact. We use the term synapses. So instead of saying this neuron contact this neuron, I use the term that this neuron form a synapse with that neuron. Are you with me? And the synapse resemble the NMJ that you have learned. Let's review the NMJ. You have the axonal terminal, you have synaptic cleft, and you have the muscle cell. Well, in your brain, it's not the muscle cell, it is another neuron. It also has synaptic cleft. Are you with me so far? Okay? Now, because of that, we have to define specifically what direction the signal flow. For example, let me do this. Okay, here's the neuron A cell body. It's an axon, and it has synapses on the second neuron body B, and this neuron in turn synapses on the other neuron. We call them C, and C go back and synapses on the B, and also synapses on another one we call B neuron. And this neuron go out, blah blah blah, go somewhere. If I look specifically at this synapse right here, okay, you see that axon right there? The neuron that sends the signal into that synapse, we call that presynaptic neuron. The one that receiving it, in this case the B, we call that the postsynaptic. Are you clear on that? Okay, and every synapse we have where the signal came from, that's a presynaptic neuron. And where is the signal go to, that's a postsynaptic. Okay, and they are vary at different synapses. For example, you see in this case, the B is the postsynaptic, right? In this case, and then my synapse right here, the B neuron is the presynaptic. So are you okay with the term pre and post?
Yes.
You try to understand it, get it. Okay, good. And then, here's a neuron. That contacts this neuron. Where you think the signal flow, in what direction? From this neuron to that neuron. So when we form the synapse right here, and that synapse, the neuron that sends the signal is called pre-synaptic neuron. The one that receives is called the post-synaptic. So So they tell you that that's how the signal flow, which one receive and which one send, right? However, on a single neuron, they have thousands of different synapses. This neuron may be, at that synapses can be a post or a pre, and the other synapse, it could be different. Depends what neuron contact and how they send to it. That's what I meant. So, this is the pre and that synapse, yes, it's always true, but when you go to another synapse, it may not be true. Are you okay with that? And that helps you understand what direction they go. So if I come over and form a synapse, yeah, that sounds scientific. I form synapses on the enterica, right here, and the pre. Where the signal go, it goes to the enterica, so she's the post. And then in turn, she may contact the other person, and then she becomes the pre, and that person becomes the post. It should help you understand where the signal flow, right? Are you sure? Look at this right here. Let's look at one of them. All right. This is the axon, came from some neuron far distant away. Are you with me? What part of this neuron right here, that the axon terminal in red color contact the cell body? Are you with me? So which one is the postsynaptic neuron? This guy. Where is the presynaptic? The cell body somewhere else. You see the axon right there. Are you with me? And in this case, they actually named the synapses by what component of the presynaptic neuron contact the postsynaptic neuron. What component of the pre-contact? That's axonal terminal. And what is the component of the postsynaptic receiver? The body. So we call that axosomatic synapse. Right? We always take the component of the presynaptic and contact the component of the postsynaptic. Can you see axon contact the body? Right? Therefore, axosomatic. You okay so far? Okay, ignore, don't cheat, look at the name. This is an axon of the presynaptic neuron contact the dendrite of the postsynaptic neuron. What do you call them? Axodendritic synapses. Are you okay so far? Okay? Can you do this? Okay, what part of the pre? Axon. And what part of the post receiving it? Axon. So you call them axonic synapses. Okay? Let me mention something else. The dendrite of the pre contact the dendrite of the post. What do you call that synapse? Dendrodendritic. The dendrite of the pre contact the cell body of the post. Dendrosomatic. You can handle it, right? And let me tell you one of the most romantic synapses there is. Body contact body. You're asking, Adil, what's so romantic? What do you call a synapses? Body of the pre, contact body of the post. Somasomatic, that's right. Just the name itself sounds romantic already, right? The question you ask, okay, you have different types. Okay? Huh? They communicate.
But I thought they didn't have any,
Morgan up and they say, why on earth the body contact the body? Have you been in high school? Okay. Sometimes they contact so much that I cannot peel them off. They don't care about dendrite, axon, it's just body to body. Okay, that's answer your question. But the question we ask is, are they occur equally? Or one are more common than the other? The answer is yes, there's certain of the synapses that much more common than the other, and that's what the next slide shows you right there. Okay? The